This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Now let's start with the example of printing the triangle in reverse. Basically, we start printing the last line is going to be our first line, and so on. The last line from the second line from the end is going to be our second, up until we end with 1 star. The formulas are going to be the same, but we just start printing in reverse. We print this line first, then this line first, and so on. So we should start from where? We started from here, from level 0. Now we should start from level 4. Everything is the same. So what should we do? We have another function which is called reverse triangle, and you see we have the same stuff. Integer I, j, k, stars, and space. And we take the lines as a parameter. For the time being, just let me copy paste this loop here that we already saw it. Now I told you we started from level 0. What if we should start from level 4? And level 4, if we have 5 lines, is what? It's lines minus 1. We decrement it by 1, lines minus minus. And we go up until I is greater or equal to 0, meaning that I is the level. We should start with the last level, with the 4th level. We decrement it by 1, up until, or down until we go to level 0, okay? So, we start from lines minus 1, starting from the 4th level, and I is above the level. We print the 4th level. We print the 3rd, the 2nd, the 1st, the 0th level, and the formula are the same. Okay? That's why we just are going to change the for loop, and the number of spaces, stars, are going to be exactly the same. Okay? So let's try this. Is this clear? I mean, the only difference that we make is this stuff here. We started from level 0 previously, and we went up until lines, meaning we started from 0. This is smaller. We went until, let's say, the lines is 5. If we want to print 5 lines, we went from 0 to 4. Now we are doing the opposite stuff. We start from 4, and we go to 0. And that's why we should decrement it by each, because I represent the number, represents the number of level. We should uncomment reverse triangle. Let's write some new lines here. Okay, 5 lines. This is it. If this is not a lot, let me give 10 lines. So these are the triangles, okay? Reverse triangle. We just did some stuff in the for loop. This example is, I mean, kind of not too important. I just wanted to show you here that inside the for loop, we can have another for loop. We can have another for loop, or we can have 2 independent for loops, as we saw it here. Okay? So you can combine 4 inside the 4 inside the 4, while inside the while inside the while, 4 inside the while inside the 4, and so on. Okay? Those are called nested composite for loops, basically, one inside another. And also it was important to show that when you have something to deal with this stuff, okay, you should probably, there is some combination, they are somehow linked, the number of lines and levels and stars and empty spaces, and you should come up with those formulas. Okay? If you do it, then your job will be just to write the code. It's not hard. And you will deal with those kind of formulas that you should come up with very often. Okay? That's why you should train yourself with this stuff. Now, there's another example that shows you how to use while and for loops. let's start. Well, let's continue. It was, yeah, I think you don't have it in today's samples, but you had it, I think, in the 5th or 6th week. I think it was the 6th week. Taylor series. If you are good at calculus, you probably know what Taylor series is about. Do you have a clue? Do you know what Taylor series are about? Yes or no? You know. You know it? So, can you explain it? Exactly. This is it. We're going to use the Taylor series for approximating sine. You know the trigonometric function, sine, you have sine, cosine, and so on. I'm going to give you a formula about sine. We are going to approximate its value to find an approximate value of sine. We are going to use for loop because series are about sums. And summing up stuff means using for loops. So, this is the approximation formula, the Taylor series, to find the sine, okay? Now, let me write it on board. And afterwards, we are going to use the program. And also, let me tell you, right in the beginning, that in the math.h library, or maybe CMath, I think it's math.h, there is formula which is called sine x, which calculates the sine of any given x, where x is the angle in radians, not in degrees Celsius, not in degrees. Okay, it's radius. So what's the difference between radius and the degrees? Well, how many degrees do we have here? 180. What about in radians?
Just pi.
It's pi. Okay. So 90 degrees is how much?
Pi.
Yeah, pi divided by 2. "45 degrees, it's pi over 4. So if we give the degrees, the angle in degrees, how can we convert it to radius? Do you know a formula about that? One degree is how much? So 100 degrees is pi radius, okay? 90 degrees pi over 2, 45 is pi over 4. And what about 1 degree? Pi over? 180, yeah. Pi over 180. 2 degrees is going to be obviously 2 multiplied by pi over 180. Okay? So x degrees is going to be x multiplied by pi over 180. This is the formula. So this is degrees, this is radius. So this is the formula we are going to use for converting from degrees to radius. Okay, because we are used to give, at least us in Europe, I suppose in Turkey also, you use degrees more, if I'm mistaken, than radius. But In Americas, usually they use radius, usually. Okay? So this is the formula to convert from degrees to radius. Now let's write this formula better. Sine x, because I'm going to write it in a way it's going to be more easy to understand when we are going to program it. We start from 0 to infinity, minus 1 to the power of n divided by 2n plus 1 factorial x to the power of 2n plus 1. Okay? So, what is this? It's equal to minus 1. Initially n is 0 to the power of 0. This is 2 multiplied by 0 plus 1 factorial. This is x 2 to the power of 0 plus 1. We have a summation here, plus minus 1 to the power of 1 multiplied by x 2 multiplied by 1 plus 1, 2 multiplied by 1 plus 1 factorial, plus minus 1 to the power of 2 x. So n is 1 here, then n becomes 2 here, divided by 2 multiplied by 2 plus 1 factorial. And you know the factorial is, so that is equal to what? Come on, this is from high school, I suppose, or primary school even. This is n multiplied by n minus 1 multiplied by n minus 2 and so on up until 1. Okay? This is the factorial. Now we're going to, so this is when we want to find sine. This is the approximation formula that we are going to use. Usually the first 3 or 4 terms are enough to find a reasonable value for sine, if you don't want to be too precise. And we are going to compare our formula with the sine x from the math library. Basically, the sine x from the math library is using this formula. Okay? So let's see the code. Just remove draw triangle and copy paste the Taylor.cpp file. Let's add it. Add existing item, Taylor.cpp. Okay, this is our code. Now first, let me run the code first. Let me see its output. Enter the angle for sine. Let me give 60. The number of the iteration for Taylor series. Iteration is basically how many terms are we going to use. Let's use 1, 2, 3 terms only. The ones that I've written here on the board. But we didn't include cin ignore and cin get. Okay, so I want to find the sine of 60 degrees with 3 iterations. And this is the function that I've used. So our value is 0.866029. Using the math.h function that I just told you about, the sine is this much, you know. You can see the difference because I'm approximating. Even this is an approximation. Okay, it says sine is a rational number, not rational, real number. It doesn't have end. Then you can continue with millions of digits after the 0. But I used only 3 terms. And you see, yeah, they're close enough, but the 3rd digit after the comma decimal comma, are not the same. If I increase the number of iterations, you'll see that they become pretty much the same. So with the first three terms, it's not. But if I give like 60 degrees, now let's say I want to use 50 terms, then they are the same. Okay? So you know now how math.h is using its has implemented its sine function. It's pretty much the same as we will do. Now let's start explaining the code. We have a function which is called convert. Basically, we are taking an angle in degrees and we want to convert it to return it in radians. And this is the formula. Okay, we just saw it on the board. Okay, that it's angle multiplied by pi. It's 3.14 divided by 180. That's the formula that we saw on board. So this is from converting from degree to radian. Now this is the function that is going to calculate the factorial. Basically, this is something that we saw when we wanted to calculate it. Same as calculating the product from 1 to n. Okay, this is a factorial. So we start from 1. When we are dealing with product, with multiplication, initially we start with 1. This one is a neutral element in multiplication. If we put 0 here, the result will be 0. If it was summation, it would have been 0. But we're dealing with multiplication. This is what factorial is about. And we start from 1 up until the value we want. And we just multiply it with 1, with 2, then with 3, with 4, and so on, up until we will reach the value, counter reaches the value we want, okay? So the factorial is equal to the old factorial multiplied by the counter, we increment by the counter. So it's 1, and factorial is 1. Then we say, okay, factorial is 1 multiplied by 1. Counter becomes 2. Is 2 smaller than, let's say, 10, if the value is 10? Yes. Then factorial is the old factorial multiplied by 2. Counter is incremented by 1. Is it smaller than 10? Yes. The old factorial multiplied by 3, then by 4, and so on. And in the end, we return the factorial. This is the multiplication function, basically, from one of the numbers from 1 to n that we saw 2 weeks ago. Now let's go to the main part. So remember, convert function converts degree to radian. The factorial calculates the factorial. Now let's see how we calculate. This is the most important function here. Calculate sine. We take the angle, which is a double, and the limit. Limit meaning how many times are we going to iterate it. Like it's 3 times here, okay? On board. We start from 0. The result will be in sinus. Sine. Why we start from 0? Because we're finding a summation. Taylor series is about summations. The iteration, how many times, how many terms are we going to take from the formula? And the power is 0. The power is this one. It's 0, then 1, 2, and so on. We want to convert, initially we find the angle, we convert it from degrees, we give it as degrees, but we convert it to radians. And this is what we are finding. The power is 2 multiplied by iteration plus 1. The iteration basically is this n. So we start from 0. And you see here we have 2 multiplied by n plus 1. So n is the iteration. It's initially 0, then it becomes 1, becomes 2. We need it because we need for the power here and also for the factorial, you see. This term here is used in the power and also in the factorial. That's why we calculate this power. And it's 2 multiplied by iteration plus 1. The iteration denominator is this one. So the angle, which is x, to the power of power, okay? We use the power function. You remember the power function from math, okay? Basically, this is angle to the power of power. If we had power ab, it's a to the power of b. So this is angle to the power of power. And angle is here the x we are talking about. So x to the power of power we calculate. Denominator is this part here under the fraction line. So we have basically denominator is about calculating the factorial of the power, okay? You see, this 2n plus 1 factorial. It's here, it's in the power, here is the factorial. So we calculate factorial. And now we calculate the sine. That's why I use sine is equal to old sine plus, because we have, okay, initially we start from 0, plus we calculate this term. We calculated the denominator here, the angle to the power of power, factorial, we calculated the denominator. Now we should calculate this part here. Basically this will be minus or plus. So tell me, minus 1 to the power of 0, how much is that? It's 1. Every number to the power of 0 is 1. Okay? So double, we are converting minus 1 to double. And this iterator is converted also to double. We multiply this one, numerator divided by denominator, this is all double. This is double here. Multiplied by minus 1 to the power of iterator. Iterator is, we start from 0 up until the limit. 0, 1, 2, 3, 4, 5, and so on. Okay? So again, this part here, minus 1 to the power of n, minus 1 to 0, minus 1 to 1, minus 1 to 2, is calculated at this part, where this fraction here, numerator, denominator, is calculated here. Numerator divided by denominator. Okay? When we calculate this stuff here, we multiply. You know that multiplication has precedence before addition. We calculate this stuff here, we add to the old sign, okay? We increment the iterator. Initially it's 0. We started from 0. So 0 to infinity, but we are going to use like 3, 5, or 10 terms, not more. We increment it. Let's say we want to use 3. 0 is incremented 1. Is 1 smaller than 3? Yes. Again, we calculate 2 multiplied by 1 plus 1. Basically, we calculate this one power, this power here. Nominator, angle to the power. So it's angle x to this power. Denominator, the factorial. This is the factorial. We go here. We find this power first. Actually, find this one here, and we multiply it with minus 1 to the iterator, to the minus 1 to 1. Okay? We multiply both of them. So we find this term here. And we add the first term and the second term. Okay? Sinus plus, and so on. So sinus now is all of those two terms. Iterator was 1, now it becomes 2. Is 2 smaller than 3? Let's say the limit is 3. Yes, it is. Again, we find this power here, 2 to the power of 2 plus 1, and so on. Okay? This is it. Is this clear? Is it hard? Did you understand it? Yes or no? Which one of you? Ilhan, yeah? Jim? Yeah, you understood it. What about you guys? You weren't here. Should I explain it again? Which part was hard for them? Okay, did you understand this formula here? Yes or no?
I get the formula, I just don't get like the turning stuff with double part.
Okay, if that's the case, then let's play the role of the compiler. Okay. Again, from start, because it's important to get, we have whiles and, formulas. We understood the convert function, I suppose, converting degrees to radius. It's straightforward. This is the formula. X multiplied by pi over 180. I suppose we got the factorial function. Did we all understand this one? Multiplication from 1 to n. Yes or no? Should I go through factorial or not? What do you say? Yes or no? Come on, give me feedback. No. Should I explain it step by step or not? Yes? Okay, tell me. Now let's go to calculate sine. So I suppose you understood this formula. Yes or no? Okay, very nice. Now let's go and let's play the role of the compiler. Okay. Let's leave it here. We have space. So, we have a box which is called sinus. Initially it's 0. Then we have an iterator. Initially the iterator is 0. And we have the power, another variable. Initially the power is 0. So those are the first 3 lines. Now I'm converting the angle, and you see that the angle and the limit are given as input here, are given as parameters. So we have the angle, and we have the limit. Limit means how many times we are going to iterate. Let's say the limit is 3, meaning from this formula we are going to take only, we are going to sum up only the 3 terms, the first 3 terms. Okay. Let's say that the limit is 3 and the angle is what? 45. We are giving it as degrees. Now we call the function angle is equal, so angle and limit are taken as parameters from the function. Everything else is 0 initially. The angle is equal to convert angle, meaning that we are giving degrees and we are taking radians. So if I send 45, what I'm going to get as a result? Come on. What? It's going to be pi over 4, okay? Because it's 45, x is 45, multiplied by pi over 180, it's pi over 4. Okay? Radians. But of course it's not going to be like pi over 4, it's going to be 3.14 divided by 4. But it's going to be in radians. Now we go and check the while loop. Okay? So the iterator initially is 0, and the power is 0. Everything is 0. So we're asking, is the iterator smaller than the limit? Is 0 smaller than 3? Yes, it is. We go inside, we find the power. The power is 2 multiplied by iterator plus 1. 2 multiplied by 0 is 0, plus 1 is 1. So the power becomes 1. Okay? We are basically finding this one. So power is this one here. This guy and this guy here. This is the power. Okay? And iterator means n. We are finding the nominator. Nominator, this is this part here. X to the power of power. We are using the power function. Basically, we are finding this guy here. So nominator is, for the time being, is angle. Oh, what can I mean, this part here. So x is the angle. Angle to power, to the power of power. And the denominator is the factorial of the power. So denominator is the power of factorial. Okay? This is the denominator. Now, initially sinus is 0. We have 0 here. Plus nominator divided by the denominator multiplied by minus 1 to the power of iterator. Iterator is 0. Minus 1 to the power of 0 is 1. So this is basically, here we are getting the sign. Okay? If it's 0, it's going to be positive. If it's odd, it's going to be negative. Otherwise, the sign is positive. So this part here is going to be positive multiplied by those two. I mean, I'm not going to, we are going to have some sum here, whatever. No. Do we have the sum here? Did I wrote it initially? No. It's sinus actually, not the sum. Okay, so we are going to have some number here, whatever. Well, it's going to be added to the initial 0. Then I increment iterator by 1. So iterator is going to become 0. From 0 it's going to become 1. By checking the while loop is 1 smaller than the limit is how much? Is 3. Yes. We go inside and find the power again and so on, okay? So this is the formula. The limit is given by us as an input. I mean, we checked it with 3, but let's check it if I give 10 or 50 or whatever. So this is it. Now in main, we don't have to do anything else except for, basic things, trivial things like we are declaring the angle, the iterator is initially 0, so we are prompting the user to enter the angle, we are entering the angle. The number of iterations that should be entered, we are giving it as an input. And finally, we calculate the sinus. Okay? This is the formula how we calculate it. We call it the angle iterator. Here this function is called. And we print. Then if we use the function that we just defined, the sine is this much. So the sine that we got from the function returned as a value is this much. So we are returning the sinus here in the previous function, and it's a double. Okay? And here we define another variable sine, but this is inside main. And it's returned from the calculate sine. We print it, okay? Now in order to compare the result from the function that we just wrote and from the math.h, and we have included math.h here in the beginning, then we do the following stuff. Okay. First, remember, we should convert, the angle is given in degrees, so we convert it to radians, and then we find the sine. Okay, and we print it. Let's run it again, and let's see it. Let's say 45 degrees with 3 iterations. It's pretty, not exactly, but pretty much the same. But if I give 10 iterations, 45, and 10 iterations, the first 10 terms of the Taylor series, the result is pretty much the same. So if you're wondering how the sine is implemented in math.h, then you know it. We are using the Taylor series. Any questions about this function? No questions. Okay. Now we are going to see another example. I don't know, maybe we won't have time to finish it all during this lecture, this hour. We'll finish it during the next one. But it's important because it's generating random numbers. Now, before giving the example, let me do some math stuff here. Have you heard about probability or not? Yeah, it's a course called Probability and Statistics and so on. It's given here in Sabancı in every engineering course. You will have to deal with that stuff a lot. So I'm going to bother you with that stuff also. Okay. Let's see, do you have the basics? Do you have the intuition for probability? I have a coin, and the coin has the head and the tail, and I'm flipping it. What's the probability of getting head? Or it's 1 over 2. 50% is 1 over 2, okay? What if I have a cube? You know the cube that maybe you have played, probably all of you. And it has 6 sides. So you roll it. The dice, basically, not you roll. How do you say dice in Turkish? I think you say zar. So you roll it, and what's the probability of getting 1? It's 1 over 6. Very nice. Okay, so we have the intuition. It's basic stuff. Now it's like this. I have 2 dice. Okay. and I roll the first one, and then I roll the second one. What's the probability of getting on both of them 1? 1 over 36. Very nice. So we are going to do this stuff here. This is our third example, or fourth for today. Rolling dice and probability. Okay. So, in order to get, let's write something, 1, or like this. So we wanted to get 1 and 1. This is the first dice. This is the number that we get in the second dice. What was the value? 1 over 6 in order to get 1 from the first dice, multiplied by 1 over 6 in order to get the 6 from the second dice, and this is 1 over 36. So far, so good. 1 plus 1 is 2. Okay. Now, another question. I want to get 3. The summation of both of the dices, of the numbers that we get from the dices, I want it to be 3. So what's the probability of getting this? Can you tell me? 1 in the first dice, and 2 on the second dice, 2 on the first dice, and 1 in the second one. So let's do the math. It's 1, 2, plus 2, 1. This is, in order to get 1 and 2, this is 1 over 36. Do you agree with me? In order to get 1 on the first dice, it's 1 over 6. In order to get 2 on the second dice, it's again 1 over 6. So 1 over 6 multiplied by 1 over 6 is 1 over 36. This is for this combination. Plus 1 over 36. So this is 2 over 36. And this is 1 over, how much? 18. Okay. Then in order to get 4, what should we do? 1, 3, yes. Then 2, 2. Then 3, 1. Something else? No, this is it. So this is 1 over 36, 1 over 36, 1 over 36. This is 3 over 36, which is how much? 1 over 12. Okay? Now if I want to get 5, what are the combinations that we have? Come on. Not only you, others also. Which one? 1, 4, yeah. Else? 2, 3. 3, 2. And 4, 1. So how many combinations do we have? 1, 2, 3, 4. Each of them is 1 over 36. So this is 4 over 36. And how much is this? 1 over 9. To get 6, come on, it's 1, 5, 2 and 3. What else? 3, 2, 2, 4, 4, 2, else 5, 1. How many? 1, 2, 3, 4, 5, 6. Something else? 4, 2 also. Yeah, we wrote it. Something else? 2 and no. 3, 3. Yes, yes. 3, 3. We don't have 3, 2 here. 2, 4. What else? 3, 3. 1, 2, 3, 4, 5. Is this all? Okay, so it's 5 over 36. This is approximately 7.25, or maybe exactly like that. Actually, it's something like this. Approximately 1 over 7. approximately, because those numbers are important, okay? The last one. The last ones. Now I'm not going to write it up until 12, since they're going to be repeated, and you'll see how. 7, we have 1, 6. Let's write 6, 1 also here. What do we have else? 2 and 5. 5 and 2. Else, what do we have? 3, 4, 4, 3. How many combinations do we have? 1, 2, 3, 4, 5, 6. So it's 6 over 36. Which is? 1 over 6. In order to get 8, how many combinations do we have? 7. So 8. Are you sure about that? You mean 7 by 36? It's not always the case. So let me check it. So for 8, we have what? 1, 7. What? 5 combinations. Yeah, it should be like that. 1, 7, 7, 1. What else? Yeah, exactly. You're getting the logics about probability. You're right. Very nice. So if we go to 12, we are not going to say we're going to get 12 combinations. No, we are going to degrees now. Okay. So 1, 7, 7, 1. What else do we have here? 2, 6, 6, 2, 3, 5, 5, 3. And 4, 4. It's 7 this time, yeah. But what about 9? And 7 over 36. Excuse me? Oh, yeah, you're right. Yeah. So you were pointing this one once I was thinking about something else. Yeah. My mistake. I'm tired. So what are the combinations we can get in order to get 8? 2, 5, yes. 2, 3, 5. 2, 6. 6, 2. What else? 3, 5. 5, 3. And 4, 4. 1, 2, 3, 4, 5. Did we have 5 combinations previously? Yes. So 8 and 6 basically have the same value here, okay? Also, if you don't trust me, you can check it. 9 and 5 have the same value. It's 4 over 36. Then 10 and 4 have the same probability. 11 and 3 have the same probability, and 12 and 2 have the same probability. In order to get 12, we can get 6 and 6, which is 1 over 36. Okay, so you have a clue about probability, and this will be our next example. Basically, we are going to roll 2 dice. And we are going to see, on average, in order to get sum of 4, how many times do we have to throw the dice? What do you think? Okay, so we want to get, let's say, sum of 4, probability of getting 12. On average, what's the expectations in order to be a kind of sure that you're going to get sum of 4? Well, let me give you a more simpler example. I'm tossing a coin. So we have head or tail. In order to be kind of sure, you can never be 100% sure, but what's your expectations? How many times you should toss the coin in order to get the tail? 2. Okay. maybe you will get it at the first time. Maybe you won't get it at the second time. Okay, maybe you need to toss it 1 million times, which is not what you expect. Okay, but on average you should expect 2. Okay, so if tossing a coin in order to get tail is 1/2, the expectation is 2. What do you think? In order to get the sum, let's say 2, how many times do we have to throw the dice? On average, after you throw 36 times both of the dice, you'll say, well, I should expect a 2, okay? What about 5? How many times you should throw dice in order to get sum 5? On average, 9 times, okay? You should expect to get sum of 9. But of course, this is probability. It doesn't always happen. So we are going to see it and demonstrate some probability stuff. And when you are going to take the probability course, probably you will remember this example, because in probability course you are going to throw a lot of dice like this. So just very briefly, let's talk about it, and I'll give you a break. Go to the dice example, and here we have 5 files. Copy paste all of them and put it to your solution folder. Just add all of them. So we have the random generator CPP and the header. We have the dice header and the CPP, and test dice. We're going to see it later on. Just put the headers at the header section, and dices are okay. Okay, now there's a library I'm going to talk about. You're going to use this library for your 5th homework, and your 5th homework will be assigned next week. So after the midterm and after the 4th assignment, I think you deserve a kind of vacation of a week or so. That's why we are more relaxed this week. We're doing some repetition stuff. Okay, but you're going to use this class for your next homework. It's called random generator. It generates random numbers, okay? For instance, Dennis, tell me a random number from 1 to 10. Okay. Your name was? Burak. Tell me a random number between 10 and 50. Which one? Between 10 and 50. 20. Okay. So now you have a clue what I'm talking about. You have the random generator constructor. So when you declare a new variable, you're going to use this constructor. But you have most important functions that you're going to use. So random integer returns random integer from 0 to max. Like from 0 to 10. Your friend Dennis said it's 7. Okay. So this is a random integer function. You have another random integer function. It takes 2 parameters, low and max. It returns a random number between 10 and 50. Okay? You can do it with real numbers, meaning you should expect something decimal. You give the low and the maximum range. So it returns, if I say, okay, your name was? Özkan. Okay, Özkan, give me a random number, a float number, decimal number, between 50 and 100. But it should be a float number. 79.5, yeah. So you have it. Now, you might wonder how the computer also generates random numbers, like you were generating. But how the computer is doing this stuff. I mean, it's not the brain. Even your brain, when you're trying to generate a number, it's not kind of really random number. Okay, you have some seed. For instance, I suspect that your friend, when he come up with 79.5, he said like, okay, let's find something on the average, and just let's put 0.5 and get the float number. This is how the brain works. Okay, this is not really a random number. It's very hard to generate random numbers. And if some of you is going to take the cryptography course, you will deal with random numbers a lot, since they're very important for cryptography. But anyway, I remember when I was a high school guy, And in my country, students are written in registers, and each guy has a unique ID number in his register for that particular class. We had the professor, then he was asking us questions. And of course, he was grading us. And he would ask something like, okay, what's your birthday? And you'll give the birthday, and he'll do some calculations and come up with a number. He's going to ask that guy. Does this happen in Turkey also? And like you're praying all places, I hope